Hello friends, in our last lecture we see about the lattice parameters, then crystal systems and crystal structures. Today we are discussing about the crystal, that is we are discussing about the Miller indices. So, Miller indices are related to directions, and second, that is related to planes. For showing the directions of crystal structures and for showing the planes which are contained in that crystal structures, so that is shown with some notations, and that is called as Miller indices. But why it is called as Miller indices? Because this is invented by the scientist named as Miller, and for that reason here the name is given as Miller indices. This is invented in the year of 1839, and the name of the scientist is William Miller, or Miller William is the name of the scientist. So, what Miller says, or what Miller find out, what is the invention? Miller gives some notations for representing the directions in crystal structures and representing the planes in the crystal structures. So, what he says, Miller indices for direction is denoted as square bracket and UVW notation, square bracket close. What is this UVW? This UVW is nothing but three different directions. Okay, in that three different directions, that is, if we consider three-dimensional system, that is x, y, z coordinate system. So in that x, y, z coordinate system, so three different dimensions are needed if the three-dimensional object is there. Okay, so Miller says that we consider these three symbols, that is u, v, w, like that. Or family of directions is represented within this type of symbols. Okay, this type of symbols are shows like this and this, and in between here he gives the values, that is u, v, w. So directions are represented with square bracket. This is very important. Directions are represented with square bracket, and in that square bracket this u, v, w symbols. And if the families are there, families of directions are there, we'll see this in detail in our next lecture. What is the family? Okay, so family of directions is represented with this u, v, w. And in this type of symbols, under this type of symbols. Okay, then next, which is related to plane. So Miller indices for crystal planes is denoted as parenthesis and HKL small letters, HKL. In parenthesis, HKL letters are used. Or family of planes, which is represented with curly brackets. Okay, so curly bracket opens, then HKL symbol, curly bracket close. Observe here, in all these four cases, comma is not used. Okay, comma is not used here. Only three values are there. Okay, square bracket. So this is represented as directions. Family of directions, representation of plane, family of plane. So Miller gives this information, this type of information. Now in this lecture, we'll focus on directions, how that directions are decided, how that directions are shown in crystal structures. In our last lecture, we see 7 different types of crystal systems are there and 14 different types of crystal structures are there. Now, if we consider the shape or the structures, crystal structure, if we consider the simple crystal structure, the simple crystal structure is cubic shape. If we consider the cube shape, now, if we consider this is simple cubic structure, okay, which is one of the crystal structure out of that 14 crystal structure, that is simple crystal structures. And if we give the coordinate system for this crystal structure, if we consider this point as the origin, if we consider this is origin, 0 point. So for representing this cubic structure, we want 3 different dimensions. So we call that distances or direct dimensions becomes, in x direction this becomes a, in y direction we take this becomes b from origin to here, and in z direction we take as c. Okay. Now, if we consider one point here, we give the dimensions for this point becomes UVW, or we say, if we consider the distances at this location, this distance becomes UVW. Okay, this distance becomes UVW, and if we draw one line from origin which is passing through this UVW, this point, call this point as point A, or point, for example, D point. If we consider D point, from this D point, if we draw one line, okay, so this is one vector. We consider this is one vector, and we give the name of this vector is vector R. Now, suppose this vector R, which is starting from origin and passes through this D point, which is having the dimensions as UVW. So this becomes the direction. Okay, and this vector, which is represented with the equation like R is equal to U A bar plus B bar plus W C bar. Okay, so this becomes the vectors for R. Okay, R direction. This becomes the vectors. And now if we see the indexing in this direction, that is R direction, the indexing becomes this U, V and W. Okay, in the direction of A, B and C respectively. So this is about the representation of this R vector. Now if we take the different positions for the points, and through that point if some direction which we want to show, then how to show that direction? Now we'll see some examples. Now, how to find out the direction for this location? If we consider this is 0, 0 location. From 0, 0 location, if we want to find out the direction at this location, okay, so what is the value for that? So if we observe here, so we go only a direction one unit. Okay, if we consider this is one unit, so in A direction this value becomes 1. If we go or see in B direction there is no any value because we want the distance from origin to here in this direction only. So in B direction no value is there, or if we consider C direction no value is there in C direction. So this value becomes 0 0 and we put this in square bracket. So our direction for this point, if we consider this point is point P, for this P point, if we want to find out the direction from the origin, our direction becomes 1 0 0. Okay, this becomes the direction. If we take the second example, now if we shift our point in that crystal structure, this is actually crystal structure. Okay, this structure is crystal structure and this is cubic crystal structure. Cubic crystal structure. This is the first type of crystal structure out of that 14 types of crystal structure. Okay, so now in this crystal structure, if we want to find out the direction at this point, if the point is located here at P point, and if we want to find out the directions, then we see what happened here. So this is A, this is B, and this is C. So if we observe here in A direction, this line is not in A direction. Okay, if we observe these distances, this line is not related to this distance. So in bracket, this value becomes 0 value. But if we see in B direction, okay, so point moves from here to here for this location. For this location, this distance must be there. Okay, so this is B distance, and if we consider this is unit distance, so this becomes one distance in this B direction. And if we see the vertical distance is also required to find out this direction. So this distance becomes again unit distance. So 0 1 1, this square bracket closed. Because for showing the directions, Miller says that we use square bracket for showing the directions. So this becomes 0 1 1 because in A direction no any point is located. In B direction the point is located and it requires this B distance to show, and this C distance is also required to show this location for point P. So in overall the direction becomes 0 1 1 for this type of condition. If we shift this position now, now in place of here, if we shift the point here, this is our P point now. Now the direction starts from origin and it comes up to P. So what happens here? This location is diagonally opposite. Diagonally opposite from origin. Now, so if we want to find out the direction from origin to here, now we observe one by one. whether we require the distance in a direction. Yes, we require the distance in a direction. So like this. Okay. So whether we require the distance in b direction, yes, we require the distance in b direction or locating the direction for p point. So one in a direction, because we consider unit distances, one in b direction. Whether we require the distance, vertical distance or the distance in c direction, yes, it requires in c direction also. And now this distance is again unit distance, and the direction is 1 1 1 for this point. If the point is diagonally opposite from the origin, so for this point the direction becomes 1 1 1. If we take another example, now consider the point is located in between this line. Okay, in between this line, the point is located here. This is our P point. Then what happens? Okay, so here the points becomes whether we require the distance in a direction for locating this P point. Yes, we require the distance in a direction, and this distance becomes unit distance. So in a direction, distance becomes 1. Okay. Whether we require the distance in b direction, yes, we require the distance. This is not located in b direction, so it is not required to give the distance in b direction. So this becomes 0 in b direction. Square bracket open. Whether the distance required in c direction, yes, it is required in c direction, but not. This is not complete unit distance. This is half of this unit distance. So this distance becomes 1/2. So here we put 1/2. Okay, and here one important rule comes, which is created by scientist Miller, who says that this type of values is not used for showing the directions. Okay, this fraction values are not shown in these directions. You show only integral values. So find out the common value and you convert this into integer value. So if we multiply this with 2 throughout, then what happens? The values becomes 2, 0 and 1. 2 into 1/2 means 1. So 2, 0, 1 becomes the direction for this point. Okay. So fraction values are not allowed for showing the direction. This becomes the rule by Miller. If we take another example, now if the point starts in all these examples, okay, point or direction we are measuring from the origin. But if the point is at the origin and if the distance starts from outside, then what happens? How to show the direction? Again we take cubic structure. Now our point is located here and we want to go at origin like this. Our point P is here and now our point is located initially here and we want to go to the origin. Then what happens? So if we start here from point P, then first we check whether this distance is in or whether if we want to find out if we want to go to the origin, whether it requires to go in a direction. Yes, it requires to go in a direction, but not in positive direction. This direction is positive direction. We want to go in this direction. So this direction becomes negative direction. This is negative in a direction. Okay. So actually -1 is there, but in Miller says that we show the negative direction by using one bar. Okay, by using one bar. This is making the rule by Miller, that is one bar in a direction. If we go, is it required to go in B direction? Yes, it is required to go in B direction if we want to go towards the origin. Okay, so this is again negative B direction. So this is also 1 minus. Whether it is required to go in C direction? Yes, it is required to go in C direction and also in opposite direction. This is plus. So in downward direction, this is minus. Okay, so negative value is there. So again 1 minus is there. So if we start from outside point and if we go towards the origin, then also it is possible to show the direction. But here, if we go in minus or negative direction, then it is very important to show that in terms of bars. Okay, so 1 bar and 1 bar. So in this way, today we learn what is the rules for showing the directions in that crystal structures. Okay, so we stop here. Thank you, and please subscribe my channel for seeing the next videos. Thank you.